We are starting statistics. You have one test in this, and we're doing 2 exercises today. It will be pretty cruisy, so if some of you end up finishing early and want to get on the PS3 or whatever, that's fine. I need to ask first, what is data? In general, I'm not even talking about maths. If I was to say, I'm collecting data, what is it?
That's what can you find like collecting a piece of information.
Yes, data is information. Well done. Now in year 9, you should have covered the idea of categorical and numerical data, but I don't know what you did in year 9. So if I was to say, I collected numerical data, what is that in the form of? Good. And our focus in year 10 is to talk about different types of numerical data. Can someone give me an example of what categorical data is? What could I collect? What piece of information could I collect about students in this class that only comes in the form of words? Eye color, hair color, yep. Versus numerical, height, weight, number of siblings, etc. Okay? That is the first part because I'm going to go into numerical data to start off your year 10 statistics topic. So, you need to be aware of the 2 different types of numerical data. Discrete numerical data is data that results from counting something. Not measuring, counting. So do you agree that I would count the number of siblings someone has?
Yeah.
Would I measure that or would I count it? I would count it. Can you get that first blue little bit there? Remember in your test you get a cheat sheet. So there will be a question asking, what type of data is this? Question? It'll be when we've done, when I've taught you the thing, okay? I think we're like a week behind on the timeline, but I'll catch you up. You guys are all right. Just getting that point, discrete numerical data is the result of counting something, for example, a number of siblings. Now the black, remember, is just notes. Because it's counted, the data can only take specific integer. So what is an integer? Just a whole number value. Do you agree that I can't have 1.36 siblings? Unless you're one of those murderers that you are talking about in psychology very soon, okay? Now, in higher level statistics, I'm pretty sure that in primary school and up until now, when your teacher just asked you to draw a graph, you would have just done any type of graph willy-nilly. That's not how it works. Certain types of data go into certain types of graphs. So I'm here to teach that to you because it's specific, because the data, the graphs don't mean anything if they're not the right type. In primary school, you probably spam pie charts. Pie charts are probably the most useless graph. They don't really show much, okay? So the first thing I need to tell you, all data should be first organized into a table. So the type of table that I want you to deal with, and you'll hear about this again in year 11 general maths, which a lot of you will be doing. Do you know why do I know that? I wrote the course. Tally frequency table displays the possible data values and how often the frequency they were counted. The tally column, you don't have to have a tally column, but it helps you keeping track of how many things you've counted already. So what I'd like you to do, get this stuff in blue, but as you're getting that down, I'm going to ask you how many siblings you have without calling your name out, okay? So get this. How many siblings? So I will put a little dash in the tally. How many?
1.
Dash. How many?
7.
Oh, crap. So is that including you?
No. That's
Oh, wow,
my
okay.
siblings.
Busy.
Yeah.
Sorry, so I wasn't prepared for that. That's cool. I'm not saying that's great. Busy. How many siblings, brothers or sisters?
2.
2? See what I'm doing with the tally? I'm putting little dashes in the tally. How many siblings?
1. 3.
What do I do after the 4 dashes to indicate 5? Do a cross?
4.
2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2. 1. 2
How many?
2, 3. You have siblings?
How many siblings? 4. 2 siblings? You got 2 brothers and sisters? Siblings?
1. 2.
2. Okay, can you get that our version of the tally frequency table too? I often find that it means more if we do stuff live because you can see it demonstrated. Can anyone tell me, through that process, can you see why it would be important to do a tally? Easier to keep track. Because otherwise I would have been like 1, freaking 7, and then I'll be like, how many am I up to? Whereas now I know the tally. How many people had no siblings in our class? None. How many people had 1 sibling in our class? 10. How many had 2? 5. How many had 3? 2. 2. And then we had 1. So can you please get down our class version of a tally frequency table? And I'll finish off the table properly because I wasn't ready for that. That's epic. Your barbecues must be crazy. Are all the birthdays in different months?
Yeah, they're pretty spread out.
Oh, wow. See, if I was a parent of that, I'd try to make them all in the 1 month so they'll get a one combined birthday. Just get that stuff in blue there so you can see we've demonstrated how to fill in a tally frequency table. I think this topic and your next one, which is about money, is a real opportunity to help your grade up because the level, we're not doing algebra anymore. None of this abstract X and stuff. And no one's come back to me and told me there's a better way of teaching than teach you how to do the thing and get you to practice doing the thing. So until that happens, I'll be consistent, okay? So what is the data column again? The data column tells you the different possibilities. Why did I freak out? I wasn't ready for 7, so I added it, okay? What is the tally column? It helps you keep count. Otherwise, I would have lost track of what number I was up to. Frequency is the actual number that matters. So the tally is a number. If you've got a ruler handy, use it, but I don't need you to use a ruler for your notes. In your test, when you're drawing graphs, please use a ruler so it's straight. So graphs are just a visual representation of the data in a table. So organize the data first, then put it into a graph. And I'm telling you now that the table is worth marks, okay? And also, if the question asks you to draw a table and draw a graph, let's say you made a mistake in the table. You'll lose a mark in the table. But if you drew a graph of that wrong info in the table, you'll get full marks for the graph. That's how marking works next year and the year after. So don't get lazy. I'm demonstrating what I want you to do, so do that, okay? So, the first type of graph, you've seen these before, a column or a bar graph. The data is along the x-axis. Frequency is along the y-axis, so how many times something happened. The columns must be separated in a bar graph. Don't have them touching each other. And a bar graph is the same, but the columns are horizontal. So I'm only going to draw a column graph here, but a bar graph would just have the bars going left to right. So I need to fix this because I don't have space for 7. So get this down for now. I'm going to extend the So 5, 6. So I wasn't prepared. 7. Did we have anyone that had 0 siblings in this particular class? No? How many people did we have that had 1? Do I have numbers on the frequency side just yet? Do I have enough space there to put 10 if it was 1 box per? It goes 1, 2, 3, 4, 5, 6, 7. I want to be able to draw my graph. So what I'm trying to demo here is look, don't stuff it up first and then erase, think first. If I did it 2, 4, 6, 8, 10, would then I have enough space? Okay? So 2, 4, 6, 8, 10, 12, 14. So 1 is going to go up to 10. So get this down as you go. 2, we had 5. So that's going to be halfway between 4 and 6. On my y-axis, 3 is 2, so 1 block. 4 is also 2. And no 5s, no 6s, and 1, 7. So it's going to be halfway between 1 and 2. If you wanted to be fancy, you can colour them in. Can you get that explanation for what a column bar graph is and our class's version for our sibling data? Okay, while people are still getting the column stuff there, you're not going to miss it because I can go over the dot plot here. I don't know if you've heard of what a dot plot is. It's very similar to a bar graph, but you'll notice in a dot plot there's only one axis line. It's the numbers along the bottom. It's got a single axis. The data values go along that x-axis. Dots are evenly spaced vertically, which represents the frequency. So I didn't leave myself enough space. So I'm going to redo this scale. Is going to go 0, 1, 2, 3, 4, 5, 6. There's going to be enough space now. So was there anyone that had 0 siblings in our class? How many people had, well, we can see on the graph there, 1 sibling was 10. So I'm going to do evenly spaced dots above 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You might notice that I tried to draw these dots halfway in the box and then on the box, halfway. It doesn't have to be like that. It just has to be evenly spaced. 2 siblings, we had 5. 1, 2, 3, 4, 5. 3 siblings, 2. 4 siblings, 2. 7, 1. All right, I'll give you time to get both of those. Can someone explain to me maybe why it's important that those dots are evenly spaced?
So it's easy to read?
Partly that, but also if they weren't evenly spaced, like if I put these 10 super close together, it's going to look
Like one. It might look like one line, or it could look like half.
yes, exactly. So what she's saying is that if I'll do in purple, if I didn't evenly space this 10, I might have 10 dots. But is that giving you the impression of how many people had 1 sibling? See, so that's why just as long as you decide what the spacing is, you're not going to be marked down. but just make sure the spacing is the same for all of your data. All right. Give 5 minutes to get that. You will not see any pie charts in year 10 or year 11 or year 12. That might give me a like. You guys know it's going to be casual day next Friday? It's for this one I'll support. This one I'll actually wear pink. It's for breast cancer awareness.
You got my paint?
They encouraging you to wear pink. So I'll be like all black, bright pink. Support.
No, I was gonna do like the full slacks and like get a suit, daily thing. This one.
So someone always finds a reason to get one of those inflatable T-Rex costumes.
Yep.
I can just get on a hoverboard or something.
Is there a
Yeah, oh, that's always.
It's always, yeah.
There's no point in supporting it if you're not going to get anything. Everyone turned up in casual. We didn't raise anything.
I can just see someone wearing a Princess Peach costume.
Well, there's that kid that wears that giant top hat. Unironically. That's so cool.
It comes in every now and then, that rat costume with a piece of cheese.
I've never seen that before.
It was a while
You
ago.
should. You're lucky.
No, but we'll do it next week.
They're fine, but like it's the dubious costume.
What if it was windy day? I think he's an anime fan.
I wouldn't doubt it. No,
That's fine. That's
Yes, but
that's recording also not the thing to say. Just in general. My fingers go back up this.
All right, quickly, can I have your attention? Is this graph symmetrical? Is it the same on either side? He's leaning to which end? The left? Yeah, it's leaning towards the lower end. So in maths, next year and the year after, you're expected to be able to talk about something called the shape of distributions. Why is there a shape? In numerical data is special because numbers have an inherent order. Can someone tell me what inherent means? If something is inherent to... I'm an Asian, I inherently eat rice and noodles. You're allowed to laugh, I'll give you the gold, I'll give you a ticket, it's alright. Let's talk about numbers. What is inherent to numbers? Do you get to choose the order of numbers? No. So 0, do you agree that it is inherent to numbers that 0 is 0 less than 1 or is it greater than 1? Less than. Which is less than? Yeah. If these numbers here was hair color, right? If we imagine that this was hair color, is there any order to hair color?
Yes.
So I could switch it.
Yes.
Maybe you just think that like blonde is the best, but or brunette or whatever. I don't know.
But there's more chance of being something than something else. Like there's more.
it's just about genes.
Yeah, but it's just. I can see what you mean, but it's like the words don't have an order to them. Like there's some situations where words have an order, like small, medium, and large. But in hair color, one is not before the other. Okay. So if my data here was hair color, that shape would be meaningless because I could just put blonde over the other side and it would be a completely different shape. But because this is numbers, is there an order to numbers? You don't get a choice. That shape is always going to be that shape. So there's 3 different kinds of shapes that you have to be aware of. This means when displayed on a graph, the shape is meaningful which allows us to describe the shape of the data distribution. If it looks the same on either side, we call it symmetrical. If it's leaning, if you have a lot of data on the low end, we say it's positively skewed. So that's a trick. Normally when you say positive, you think more. But where is there more data in this graph? On the low end or the high end? Where is there more data? Where is there a peak of data? On the low end. So when there's more data on the low end, we say it's positively skewed.
Do I have to draw this?
Can you remember it?
Yes.
Okay, we'll see. I'll remind you of this day. When I mark your test, I'll point out that question. And if you remember it, I'll be like, bro fist. If you don't, I'll be like,
Like, do I have to draw the...
I just punch her in the head.
You do that.
if you get you don't have to draw it perfectly, but if you get something that tells you that if it's the same on both sides, we say it's symmetrical. If your graph is leaning on the left, positively skewed, and if it's leaning to the right, which is the high end, then we say negatively skewed. But I will give you time now anyway, because there's just one more point about outliers, and then you'll work for 40 minutes. If you can vaguely remember what our sibling graph looked like, what's the skew of our particular sibling to positive? Well, no, okay. Maybe I should believe. You got. Positively skewed because there was more data on the low end, the ones. Right, get what you need from there. Do people do Halloween around this area?
It dropped off
Trick or
last year.
treating? It dropped off.
There's like 3 people that accepted trick or treaters last year. Everyone else said no.
It'll work out if I set up the automatic sprinkler.
Yeah, you have to go out
Trick or
pretty-
treat!
Yeah, you have to go out pretty far for people that haven't canned it. Yeah.
I
Do you know
went,
where good spots are?
I went hard with the group.
I think you would just assume if they had decorations out, you'd get.
Yeah.
Flag is a good spot.
I went
It's
out.
not for me. I'm
There's no...
a 40-year-old man.
There's originally one. I hate
Just
when
clown, like just clown suit.
When you become too long,
Yeah.
it's the one that you can take.
You just walk up to someone's house and
There's
like,
only one
hey,
house in my place.
trick or
And
treat.
Darren just moved out.
Is that for your son? No.
It's the one
Give
that
me that
you
time
can
out.
take.
Oh, how close is
Yeah. It's the one.
Don't go out in Hallicove. I used to live in
Stop
Hallicove.
saying names.
So did I.
Sketchy.
I remember back in Cleveland, I was seeing a story about
There are some
guys
places-
stab people.
You have to drive all the way, but like, the one
I went with the
I
group last year and there was like.
Mm-hmm. No Hackham either?
There's like no.
Just clown suit.
Yeah, we didn't get anything last year, so we just went to Coles and bought like party mix and we got
Trick or treat at the shopping
was
centre.
Yeah, it was
Wait,
great.
I was working last year, so
We were just
I just
eating
bought
M&Ms
like 2
and like
boxes
a
of
wall. It was
chocolate.
great.
I was working last year, so I just bought 2 of the large top deck blocks of chocolate.
Oh, have you seen they came out with triple deck? It's so top deck is milk chocolate, white chocolate. Triple deck is milk chocolate, white chocolate, mint chocolate.
Give
Oh, it's so
me!
good.
Oh, give me! How much?
It's like $2 like normal.
Oh, that's awesome.
Yeah, and
I have like 50 cents a month.
Keep in mind the recording still. They will if you say the names enough. Jeez.
I'm not gonna say anything.
yeah, when I finish my ankle,
All right, there's a little bit of chat. So let me finish this off with the idea of outliers. The last thing we need to consider is the idea of outliers. What is an outlier? It's a data value that lies outside, either much larger or much smaller than the general trend of the data. This is the first time in my 15 years of teaching a lesson like this that I had an outlier for the number of syllables. Thank you. Okay? Do you agree that that particular piece of data
yes.
is far away from the general trend of the data? So outliers can be identified because they stick out far away from the main shape seen on a graph. You don't even need to copy this. You can just get our graph and put a circle around the 7. That's an outlier. If we had heaps of people that had 7 siblings, then it's not going to be an outlier anymore. Okay? but because we only had one and it sticked out and there was like 2 gaps there, we call it an outlier. Yeah? So just get an outlier is a data value that lies outside, is much larger or smaller than the general trend of the data. And actually, I don't actually need to skip down because the last point that you need to get down is that you cannot ignore outliers unless they're a mistake. So in math, some of you are doing psych, you'll have, and you're all doing science, you might have a bit of data that looks really weird, okay? And unless you can track down that you accidentally typed it out incorrectly or you stuffed up the experiment, you have to accept that that data is real. We can't just ignore that. That's real. See? Even though it's an outlier, that's a legitimate piece of data, yes?
But could I possibly say that that might not change the overall?
That's where you get your marks from, baby. Like, that's where the discussion comes in. You'll be like, if I was looking at the overall trend of the data, the majority of people, it's positively skewed, and the majority of people have one sibling. However, there was one outlier, and then you can go into the reasons that you might think for that. So I'm not going to move this down because the last point is just to say, don't ignore outliers unless they're a mistake. I'll stop the recording so you can chat.